Imagine a 4-ton steel school bus soaring through the freezing dark void of space at 5,000 miles per hour without any steering wheel. It tumbles head over heels through the absolute silence, heading on a collision course with a world where no human has ever walked. Right now, on the far side of the moon, a strange double crater sits carved into the ancient rock because of an 8-year-old mistake. The metal rocket stage has completely turned into dust, but the mystery it left behind is changing how scientists view deep space forever. If you're fascinated by the secrets of our universe and want real space stories told in simple words, tap that subscribe button right now. We cover the greatest cosmic mysteries every single week, so join our community of curious minds and never miss a deep space revelation. To truly understand how a giant piece of human space trash ended up blasting a double crater into the lunar soil, we have to travel back in time to February of 2015. On a warm, humid evening in Florida, a giant rocket built by Elon Musk's space company stood tall on the launch pad at Cape Canaveral. Its goal was to carry a very important climate monitoring satellite into the deep ocean of space. The satellite was called the Deep Space Climate Observatory, designed to travel nearly 1 million miles away from Earth to keep a constant eye on dangerous solar storms heading toward our planet. The launch began with a blinding flash of orange fire and a deep roar that shook the ground for miles around. The powerful lower half of the rocket fired its engines, pushed the satellite high above the clouds, and then detached cleanly to fall back toward the ocean. Once the first stage fell away, the rocket's upper stage took over the mission. This upper stage was essentially a huge metal cylinder packed with powerful rocket engines and thousands of gallons of explosive liquid fuel. It fired its engines with incredible force, accelerating the satellite toward a special gravitational parking spot far beyond the orbit of our moon. Once the upper stage reached the proper speed and direction, it released the climate satellite into its deep space orbit. Normally, when a rocket stage finishes its job close to Earth, Mission Control uses the tiny bit of leftover fuel to push it down into our atmosphere. The thick blanket of air around Earth acts like a fiery furnace, burning the metal structure into microscopic dust long before it can reach the ground. But this particular rocket stage was already far too distant for a safe return burn. The engineers facing this situation had a massive technical problem with no easy solution. The upper stage had used up almost every single drop of its liquid fuel to get the heavy satellite out to its distant destination. It did not have enough energy left to turn around and fly back toward Earth's atmosphere. At the same time, it did not have enough speed to break completely free from Earth's gravitational pull and escape into the vast solar system. Instead of burning up or flying away forever, the 4-ton piece of rocket was stranded in a strange cosmic limbo. It was trapped in a complex gravitational tug-of-war between the Earth, the Moon, and the Sun. Scientists originally expected that the empty metal shell would simply drift harmlessly through high orbit for millions of years. For decades, space agencies around the globe had left old rocket stages floating in deep space without any major problems. Space is unimaginably vast, and the odds of a tiny metal cylinder hitting a specific celestial body seemed far too small to worry about. However, what actually happened over the following years was completely chaotic and unpredictable. The combined gravitational pulls of the Earth, the Moon, and the Sun began tugging on the abandoned rocket from 3 different directions at once. To make matters even weirder, the gentle pressure of sunlight hitting the metal surface acted like a faint wind, constantly pushing the light structure off course. Over months and years, these gentle invisible pushes twisted the rocket's orbit into a wild, looping roller coaster shape that changed every single week. This huge gap between what scientists expected and what actually occurred matters because space is not a neat, predictable highway. When we leave heavy human objects drifting in deep space, we cannot easily predict where they will end up over long periods of time. Tiny shifts in gravity and light pressure can turn a peaceful, drifting orbit into a dangerous trajectory heading straight for a collision. The abandoned rocket stage had effectively transformed into a rogue human-made asteroid, wandering blindly through our cosmic backyard without anyone steering the wheel. For 7 long years, the abandoned stage drifted silently through the dark, completely forgotten by the general public. But thousands of miles away in Maine, an independent astronomer named Bill Gray was keeping a very close eye on it. Bill Gray creates highly accurate software used by professional observatories all over the world to track near-Earth asteroids and space junk. In early January of 2022, while feeding new telescope observations into his computer models, he noticed a shocking pattern in the tracking data of this specific object. His calculations revealed that the 4-ton rocket stage was on a direct impact path with the Moon. It was not going to swing past harmlessly, nor was it going to miss by a comfortable margin. The math proved it was locked onto a direct target on the lunar surface, moving at over 5,800 miles per hour. Because the object had been dead for 7 years, there was no engine power left, no fuel, and no human control room that could send a command to steer it away. The collision was completely inevitable, locked in for March 4th, 2022. Did you know that astronomers track thousands of dead satellites every single day to prevent space collisions? If you find it crazy that a forgotten rocket could wander through space for 7 years before crashing, smash that like button right now and leave a comment sharing your thoughts on tracking space junk. When the news of the upcoming moon crash broke across the global scientific community, astronomers were thrilled rather than concerned. The moon is an airless, barren world with no cities, no atmosphere, and no native life forms that could be harmed by an impact. In fact, planetary scientists quickly realized that this accidental mistake offered a rare, golden opportunity. They were about to watch a massive, high-speed impact event unfold on the moon, and they knew the exact time and location days before it happened. To appreciate why scientists were so excited, we have to look back at space history. During the famous Apollo missions in the late 1960s and 1970s, NASA intentionally crashed several empty Saturn V rocket stages into the moon on purpose. When those massive rocket boosters slammed into the lunar dirt, seismic sensors left behind on the surface by Apollo astronauts recorded the shockwaves traveling through the ground. Those early experiments proved that controlled rocket crashes could act like giant hammers, helping scientists map the interior structure of the moon. Normally, when natural space rocks smash into the moon, nobody is watching. Asteroids strike completely at random, leaving fresh craters behind that scientists only stumble upon years later when reviewing routine satellite maps. But this upcoming crash was completely different. Astronomers could calculate the exact minute of impact and direct powerful space telescopes toward the target area. They hoped to study the physics of high-speed crater formation, see how much dust was kicked up, and analyze the deep lunar soil exposed by the violent blast. Here's the part of the story that catches almost everyone completely off guard. Scientists originally expected the impact to create a single, standard dish-shaped hole in the lunar ground. According to well-established physics models of asteroid strikes, a 4-ton cylinder traveling at nearly 6,000 miles per hour should scoop out a clean, round crater. They calculated that the resulting hole would measure about 50 to 60 feet wide and be relatively shallow, matching the marks left by historic Apollo rocket stages intentionally crashed into the moon back in the 1970s. What scientists actually discovered when they finally located the impact site months later threw the entire space industry into total confusion. When satellite cameras snapped ultra-sharp photographs of the crash zone, they did not see one neat, round crater. Instead, the lost rocket had smashed into the surface and created a bizarre, distinct double crater. There were 2 separate overlapping holes cut into the gray dirt, one measuring 62 feet across, and the other measuring 52 feet across. This unexpected double crater raised major red flags for aerospace engineers and physicists who study hypervelocity impacts. A standard rocket stage is essentially a hollow metal tube with a very heavy engine at one end and lightweight empty fuel tanks at the other. When a normal rocket hits a surface, the heavy engine at the back drives the main impact force, producing one single crater. For this object to create 2 side-by-side craters of roughly equal size, it meant there had to be massive, heavy structures located at both ends of the object when it struck the ground. This weird physical detail touched off a heated global investigation among astronomers. How could an empty upper stage have double heavy masses on opposite ends? Bill Gray, the astronomer who originally predicted the crash, decided to double-check every single piece of historical radar and orbital tracking data. When he traced the object's path all the way back to its original launch in 2014, he realized he had made a subtle identification error. The crashing object was not the SpaceX rocket from 2015 after all. Instead, the 4-ton piece of metallic space debris was actually an upper stage booster from a Chinese lunar mission launched in October 2014, known as Chang'e 5T1. This Chinese rocket had spent over 7 years orbiting quietly in deep space, tracked by automated systems under a temporary classification label. When scientists realized the object belonged to China, the presence of 2 separate craters suddenly became an international space mystery. When journalists asked Chinese officials about the lost rocket stage, the government publicly claimed that their booster had safely re-entered Earth's atmosphere and burned up years ago. However, tracking data provided by the United States Space Command contradicted those official statements. Military radar systems had tracked the Chinese rocket stage continuously since its 2014 launch, proving beyond a shadow of a doubt that it had stayed in orbit until it slammed into the moon in early 2022. The double crater strongly implied that China had mounted an undisclosed, exceptionally heavy experiment or structural payload to the top of their rocket stage. Because rocket designs are usually closely guarded national secrets, space experts around the world could only speculate about what extra hardware was riding on that upper stage. The strange mark left on the lunar dirt proved that secret space hardware cannot hide forever when high-speed physics comes into play. What do you think was hidden on top of that secret rocket stage to cause a double crater? Drop your wildest theory in the comments right now, and hit that subscribe button to stay updated on all our deep space investigations. Whether the rogue cylinder belonged to SpaceX or China, The underlying reality remained unchanged. Human technology had violently altered the surface of another world. The impact took place on the far side of the moon, an area that is permanently turned away from Earth due to the way the moon's rotation locks with our planet. Because millions of tons of solid rock block direct line of sight communication, radio signals cannot reach Earth from the far side, and ground telescopes can never see what takes place on that hidden surface. When the rocket struck the moon at over 5,000 miles per hour, the energy released was equivalent to exploding several tons of high-grade military explosives. The metallic shell did not simply crash and crumple. The sheer kinetic energy instantly transformed the metal and target rock into superheated vapor. A brilliant flash of heat ripped through the vacuum, throwing thousands of tons of pulverized lunar soil high into the sky before it rained back down over the surrounding craters. Scientists originally expected that orbiting lunar satellites would immediately snap bright, clear images of the rising dust plume. NASA operates a spacecraft called the Lunar Reconnaissance Orbiter, which flies low over the lunar landscape, taking high-definition pictures of the ground. Mission controllers hoped the satellite would pass over the impact site just minutes after the blast to capture the settling dust and verify the exact moment of destruction. However, finding a brand new 50-foot crater on a celestial body as large as the entire continent of Africa turned out to be an exhausting challenge. The NASA satellite was in a completely different orbital position when the impact happened, meaning it could not record the initial crash. It took team members nearly 3 full months of painstaking computer searches, systematically comparing old satellite maps to newly taken photographs, before they finally spotted the dark, fresh mark stamped into the gray dust. Pay close attention to what scientists uncovered next, because it changed how we view the physical history of the moon. The rocket did not hit a barren, flat plain. It slammed right near the edge of Hertzsprung Crater, an ancient geological formation billions of years old. The surface soil in that region, known as regolith, had laid untouched since the early days of our solar system. The sudden, violent arrival of human space junk disturbed layers of lunar soil that had sat quietly while dinosaurs walked on Earth. To understand why this lunar soil matters so much, we have to explore what regolith actually is. Unlike dirt on Earth, which is soft and rounded by wind and water, lunar regolith is made of tiny, sharp glass shards created by billions of years of meteorite impacts. Without an atmosphere to weather down the rough edges, these microscopic particles remain razor sharp. When the heavy rocket stage struck this delicate surface, it blasted those ancient glass particles outwards for miles, permanently scarring the surrounding landscape. This stark event highlights a shift in our relationship with space that is unfolding right now. The region surrounding Earth and the Moon is no longer a pristine, untouched wilderness. Right now, there are tens of thousands of pieces of space debris circling our planet at blinding speeds. These objects range from dead-weather satellites and abandoned booster rockets to tiny paint flecks and frozen coolant droplets moving fast enough to punch straight through thick solid steel. Originally, early space pioneers believed that the pure vastness of space would automatically solve our waste problems. For decades, the dominant philosophy among spacefaring nations was out of sight, out of mind. Engineers built rockets designed to carry satellites into orbit, but they rarely planned how to safely dispose of those massive metal tubes once the missions were finished. They assumed the infinite dark void was simply too vast for human activities to ever cause long-term environmental damage. What we are witnessing right now proves that early assumption was dangerously wrong. Space junk does not magically disappear or melt away in a vacuum. It remains locked in orbit for decades, drifting unpredictably, colliding with other objects, and breaking apart into thousands of tiny, sharp fragments. The moon impact of 2022 served as a dramatic global wake-up call, proving that our orbital trash problem is no longer confined to low Earth orbit. It is spilling over onto the moon itself. To see how bad the situation around Earth has become, we have to look at the numbers. Scientists estimate there are over 30,000 objects larger than a soft drink concurrently floating in orbit. Even worse, there are over 1 million smaller pieces of metal and debris between 1 and 10 centimeters long. Because these objects travel at orbital speeds of up to 17,500 miles per hour, even a tiny bolt carries the kinetic impact energy of a heavy hand grenade. If a piece of floating trash collides with an active satellite, the results are catastrophic. The satellite does not just stop working, it explodes into thousands of new, sharp fragments that bullet through space. This is where the real danger lies for humanity's technological backbone. Almost every part of modern life on Earth relies on the constellation of satellites spinning silently overhead, from financial transactions to aviation safety networks. If humanity does not change how it operates in orbit immediately, we risk triggering a catastrophic cascade scenario known as the Kessler Syndrome. Named after NASA scientist Donald Kessler, who first proposed the concept in 1978, this is a nightmare environment where the space around Earth becomes so choked with high-speed debris that collisions become constant and automatic. One single collision between two dead satellites generates thousands of flying fragments, which then smash into other working satellites, creating millions of additional deadly projectiles in an uncontrollable chain reaction. Imagine a future where a thick, swirling cloud of artificial shrapnel surrounds our entire planet, making it far too dangerous to launch new satellites or send astronauts into space. In that scenario, global navigation networks like GPS would fail, weather forecasting systems would go dark, and worldwide communication networks would collapse. Humanity would find itself effectively trapped on Earth, locked out of space exploration for centuries because of garbage we left behind today. What would bother you most if space debris destroyed our satellite network, losing your phone's GPS navigation or losing global internet connectivity? Share your pick in the comments below and hit that subscribe button if you want to stay ahead of the most critical space stories facing our planet. The risk is not just theoretical. We have already seen real-world near misses that terrified space agencies. In 2009, an active American communications satellite collided directly with a dead Russian military satellite 500 miles above Siberia. The two spacecraft smashed into each other at 26,000 miles per hour, instantly shattering into more than 2,000 large, trackable metal pieces, and countless smaller fragments that remain in orbit to this day. Even the International Space Station, where human astronauts live and conduct science, has to perform orbital maneuvers to dodge space debris. On multiple occasions, astronauts have been forced to close the protective hatches and take shelter inside their emergency return capsules because a piece of untracked space junk was passing uncomfortably close. These nerve-wracking moments remind us that leaving trash in space directly puts human lives in danger. To make matters even more complicated, space debris is not evenly distributed around our planet. Most human satellites operate in specific orbital lanes where conditions are ideal for communication or weather tracking. Low Earth orbit, which sits between 100 and 1,200 miles above the surface, is the most crowded region of all. Because thousands of satellites are packed into this thin shell of space, the density of flying debris is growing at an alarming rate every single year. When scientists look at deep space orbits beyond the moon, the problem takes on a completely different shape. In deep space, tracking objects becomes exponentially harder because radar signals from Earth grow weaker over long distances. A rocket stage floating near the moon reflects very little sunlight, making it almost invisible to optical telescopes unless astronomers know exactly where to look. That is why the rogue Chinese rocket drifted undetected as a mystery object for 7 full years before anyone realized it was on a collision course with the lunar surface. Scientists and engineers around the world are now working frantically on innovative technologies to clean up space before we reach that point of no return. Several international space companies are currently testing robotic capture satellites equipped with giant nets, mechanical arms, and specialized harpoons designed to snag dead satellites and drag them down into Earth's atmosphere to burn up. Other teams are developing ground-based laser systems capable of nudging space junk onto safe decay orbits without touching the objects at all. At the exact same time, international space policy is undergoing a massive transformation. Leading space agencies are beginning to enforce strict guidelines requiring any company or government launching a rocket to prove they have a clear disposal plan. Modern rockets are now being built with extra fuel reserves specifically reserved for a controlled deorbit maneuver, ensuring that upper stages either return safely to Earth or enter designated graveyard orbits far away from active satellites. In addition, space companies are exploring automated self-destruct mechanisms and deorbit sails. These thin, lightweight sails unfold at the end of a satellite's lifespan, catching the very faint atmosphere at high altitudes to create drag and pull the dead satellite down into the atmosphere years faster than it would fall on its own. Every rocket stage successfully removed from orbit is one less potential collision waiting to happen. Another exciting development in space cleanup involves using artificial intelligence to track orbital debris in real time. Advanced computer algorithms can analyze millions of telescope images every second, identifying hidden pieces of space junk and predicting their orbits years into the future. By using smart AI monitoring systems, space agencies can warn satellite operators about potential collisions days in advance, giving them enough time to fire tiny thrusters and steer clear of danger. However, technology alone cannot solve the space debris crisis unless all spacefaring nations agree to work together. Right now, international space laws are outdated and difficult to enforce across borders. Under current treaties written back in the 1960s, a country owns every piece of hardware it launches into space forever. That means one country cannot legally capture or remove another nation's dead satellite without explicit permission, even if that dead satellite poses an immediate danger to everyone else in orbit. How do you think international leaders should handle untracked space junk floating in deep space? Do you believe one nation should have the right to clean up another country's abandoned rocket? Drop your thoughts in the comments section below and subscribe right now to stay informed on the future of space exploration. The accidental creation of a double crater on the moon is a powerful story about human ambition, unexpected physics, and our rapidly expanding footprint in the cosmos. It stands as a vivid reminder that every single object we launch into the sky leaves a permanent mark on the universe around us. The pair of overlapping craters cut into the far side of the moon will remain untouched for hundreds of thousands of years, a silent human monument carved into another world. As humanity prepares to return to the moon through upcoming crewed exploration programs like Artemis, we must decide how we intend to treat our celestial neighbors. Will we allow the solar system to become a cluttered, hazardous scrapyard, or will we choose to explore the cosmos with wisdom and care? The actions we take over the coming decade will dictate whether space remains an open gateway for exploration or a closed door blocked by our own debris. Think about what this means for the future of humanity as a species. We are standing on the threshold of a brand new space age, where regular people may one day travel to lunar bases or live in colonies on Mars. But to achieve those incredible sci-fi dreams, we must first master the basic responsibility of managing our orbital environment. Treating space with respect is not just about keeping the night sky clean. It is about protecting the future of human civilization itself. The story of the rogue rocket that struck the moon proves that even our mistakes can teach us vital lessons if we pay attention. The unexpected double crater forced scientists to re-examine hypervelocity impact models, leading to better spacecraft designs and improved orbit tracking software. Because of that single 4-ton piece of drifting metal, we are now far better prepared to track near-Earth asteroids and protect active satellites from unseen dangers in the dark. Every time we look up at the moon in the night sky, we are looking at a world that holds the history of our solar system. For billions of years, that pale gray ball has recorded the impacts of giant asteroids, comets, and cosmic dust. Now, for the first time in 4.5 billion years, the moon is also recording the history of human engineering. That tiny double crater on the far side is proof that humanity's reach has extended far beyond the boundaries of our home planet. If you found this deep space investigation exciting and want to support honest, real scientific storytelling without exaggeration, please take a second to subscribe to our channel, turn on all notifications, and hit the like button. Tell us in the comments, should private space companies be held financially responsible for cleaning up their rocket stages, or is space junk just an unavoidable part of exploring the unknown? Share this video with a friend who loves space, and thank you so much for watching.